At the edge of our solar system, there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the Sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort cloud after drifting away from the Sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the Sun's gravity from another planetary system. And then, this planet came to rest somewhere in the Oort cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort cloud and its enormous size, we may never really figure out what is lurking out there.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper belt. The Kuiper belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from two special space surveys called Eras and Akari. These two looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from Akari, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both Eras and Akari, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The two detections weren't in the same spot in both surveys, and the way they appeared in the Akari map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier. But of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be two unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun.
So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Iapetus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Iapetus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Iapetus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Iapetus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Iapetus was quite far away from it. If Iapetus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
This planet is as light as that piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but let's call it the Cotton Candy Planet. It's located around 1,200 light-years away from us. Sure thing we'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin, 50% more massive. It has an extremely low density combined with other factors, such as high temperatures and the infrared brightness of its host star, that make it look special. May I have a close-up here, please? Thank you. See how fluffy it is? Right now, you understand that it would be impossible to stand on its surface. Anyways, it's not often that you meet something like WASP 193b at a planetary party. Such planets might be fluffy because they're getting cooked by their parent stars, puffing up like a marshmallow that's seen too much campfire action. But the thing is, if you're that close to your star and mostly made of a hydrogen-helium cocktail, you're not gonna keep your puffiness for long. It's like trying to hold on to a balloon during a hurricane. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 100-07b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet is a copycat of Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure, but WASP 100-07b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-cam. They spotted clouds made of the stuff that builds beaches, silicate, or as you might know it, sand. Imagine sandcastles in the sky. Those sound clouds are way up there in the penthouse suite of WASP 100-07b's atmosphere, where the thermostat reads a breezy 932 degrees Fahrenheit. Normally, you'd need 1,832 degrees Fahrenheit to cook up this kind of cloud, so scientists are scratching their heads. How did those grainy puffs get all the way up there? Turns out, WASP 100-07b might be running its own sandy water cycle, but with scorching silicates instead of H2O. Silicate particles get whooshed up from the sizzling lower levels by some sort of cosmic elevator, and then they cool off, party together as clouds, and sprinkle down a silicate drizzle. Nobody's packing sunscreen for this kind of sandstorm, though. Now look at this Kepler planet family located in the Kepler 51 star system. This cosmic three-pack hangs around 2,400 light-years away, looking huge but having the same density as your favorite snack. And it's cotton candy yet again. Scientists have been digging into what these space treats are made of. They now believe these puffball planets are big hydrogen-helium gas balloons with a generous smearing of methane haze. It also turns out these planets might be going through a cosmic downsize. Now, let's talk about a planet called Mascara 5b. Nope, it doesn't look like one of those cosmetic tubes from your mom's drawer. Scientists say it's one of the hottest planets ever discovered. They call it an ultra-hot Jupiter, showing off its impressive size, almost twice as big as our very own Jupiter. The dayside temperature is around a scorching 4,892 degrees Fahrenheit, while the night side hits 4,172 degrees Fahrenheit. No chance for any sort of life to survive out there. Actually, it's the second hottest nightside temperature ever recorded.
To put it in perspective, the temperature of molten lava sits between 1,292 degrees Fahrenheit and 2,282 degrees Fahrenheit. So, the planet is a whole lot hotter than this scorching liquid rock. Its temperatures even surpass the melting point of most metals, which is around 3,632 degrees Fahrenheit. Scientists mention that the insane heat on this planet is comparable to the exhaust of a rocket engine. Back in 2005, one famous star called… Wait, is that a name or a phone number? Whatever. So, turns out this star has a hot sister, and they have very similar names. This hot sister has B at the end. Well, this place looks like something from a sci-fi movie as it rocks a mesmerizing blue marble vibe, according to NASA. Such an appearance results from an atmosphere packed with hazy clouds laced with glass. The rain on this planet is glass-filled precipitation that likes to fall sideways, thanks to fierce winds blowing at a speed of 5,400 miles per hour. And yeah, it's the hot sister for a reason. Scientists have measured the daytime temperatures in this nightmarish world. It's around 1,700 degrees Fahrenheit. So when it rains on this planet, it's more like molten glass pouring down instead of your typical waterworks. You may not know it, but space is swarming with wasps. I'm talking about planets called WASP. Meet WASP 76b. This sizzling hot Jupiter-like planet is so out of this world, it rains iron at night there. The daytime side is no less of a fiery nightmare. The temperature there is about 4,300 degrees Fahrenheit. WASP 76b may be slightly smaller than Jupiter, but don't underestimate its grandeur. This fireball is located 640 light-years away from Earth, and its terrifying climate is the result of one seriously extreme orbit. You see, these gas giants are fittingly known as hot Jupiters. They like to keep it hot, so they orbit way too close to their scorching host stars. In this case, WASP 76b is nearly 10 times closer to its star than Mercury is to our Sun. That's way too close for comfort, leaving this rebellious planet tidally locked to the star. So, while one side basks in eternal light, the other is trapped in perpetual darkness. 55 Cancri E is a total gem. It's the raddest super-Earth ever spotted. Scientists initially believed it was packed with so much carbon that its insides were blinged out with diamonds, thanks to insane pressure and sizzling temperatures of 4,892 degrees Fahrenheit. But researchers put a dent in the diamond hype, showing there was actually less carbon than we had originally thought. Well, diamonds aren't actually that rare and expensive after all. They're just well marketed. The last destination for today is GJ 1214b, located 40 light-years away from Earth. This planet is like a supersized Earth, almost 3 times bigger in diameter and a whopping 7 times heavier. It orbits around its red dwarf star faster than you can finish a pizza, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some super cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated.
This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Halla. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Halla rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Halla isn't bothered in the slightest. Scientists call Halla the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baekdu was once 2 stars, a white dwarf and a red giant. Halla orbited them both, and they merged before the red giant fully expanded. This allowed Halla to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Halla formed from the debris created when the 2 stars merged. In this scenario, Halla would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Halla and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system. Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle in some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though. This ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but two at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours, but that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm, heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles. You're in your galactic space cruiser on your way to Outpost 52, delivering supplies for the small colony there, when alarms begin going off. You scan your displays, but something catches your eye before you can work out what's happening. You don't need a view screen, as the front section of your ship is transparent, like a one-way mirror. A colossal orange and purple cloud is sweeping towards you. There's no time to analyze it. You put the ship into a dive, as steep as it will go. The alarms go crazy, but you're too focused on getting out of danger. The ship rattles, and you think it will break up, but your ship is fast and powerful, and somehow you manage to get underneath it. You look up and see the gigantic plasma cloud go soaring past. Curiosity has bitten you, and you decide to follow it. You program your computer to analyze it. Soon the information is coming back, and you can't believe what it's telling you. This plasma cloud is a wrecker of galaxies. It and others like it have been ending galaxies before their time. You recall your studies back on Earth when you were just a young pilot. There have been studies as far back as the 21st century as to why galaxies were mysteriously ceasing the formation of new stars, causing them to end ultimately. Stars form from thick clouds of gas that have become extremely cold. They condense and, over time, collapse into solid compact matter. There's a famous photograph taken by the Hubble Space Telescope. Most people have seen it. It's called the Pillars of Creation. It's the Eagle Nebula, where stars are forming. They call these environments star nurseries. It's a pretty cute concept if you think about it. But there's a bad guy lurking, and you're following it. It's a vast star wrecker. The wrecker rushes in and sweeps the gas out of these star-forming galaxies at an accelerated rate, preventing stars from forming in the first place. It's like a giant broom. But rather than cleaning up, it's ceasing up, bringing new galaxies to a premature end. Now that you know how dangerous it is, it's best to hang back a bit. Let's see if we can see it in action from a safe distance. It had been a long-standing mystery why some galaxies don't birth new stars. The star wrecker is smart. It hangs around large galaxy clusters. There's one in particular, the Virgo cluster. This is the one that scientists studied and came across the star wrecker. The nearby Virgo cluster is 7 million light-years across and contains thousands of galaxies. When I say nearby, it's about 65 million light-years from us. Not exactly a weekend space cruise away, but it's pretty close in galactic terms. The cluster hurtles through the superheated plasma at speeds of up to 1,000,000 miles per hour. The cluster forms the basis for the large Virgo supercluster, of which the local group, where our Milky Way resides, is a member. Its proximity to us makes it easier for scientists to study. It's also one of the most extreme regions of the universe that we know of, currently. Who knows what else is out there? The Virgo cluster is also unusual, as it's still forming new stars, and we can observe them, such as in the famous Hubble nursery photo. A galaxy in this cluster is called the Messier 87. It was discovered way back in 1781 by a French astronomer named Charles Messier. It looked a bit fuzzy to him, so he called it a nebula without stars. More information on what it was couldn't be ascertained until the 1920s. Messier was well respected and in his lifetime discovered 13 comets. He was born in rural France, the 10th of 12 children. When he was 14, he witnessed a tremendous six-tailed comet in 1744. It was astonishing and was visible to the naked eye for several months. Its effects were dramatic and unusual. It was so bright that it's been recorded as the 6th brightest in history. 4 years later, young Charles saw a solar eclipse from his hometown on the 25th of July, 1748. He knew then that he wanted to explore the world of astronomy. It was meant to be. A lunar crater and an asteroid have been named after him. Nothing is mighty, however, like the Messier 87, or M87. It's a supergiant elliptical galaxy with trillions of stars. It's the second brightest galaxy within the northern Virgo cluster, making it popular amongst astronomers and amateur enthusiasts. Elliptical galaxies are older, low-mass stars with minimal star formation activity. Large numbers of globular clusters surround them. They make up roughly 10 to 15% of the Virgo supercluster. M87 has a supermassive black hole at its core. The black hole was photographed using data collected in 2017 by the Event Horizon Telescope, EHT. It was announced excitedly to the world in 2019. In March 2021, the EHT collaboration revealed a polarized-based image of the black hole for the first time. It was a pretty exciting event. It was the first time that a black hole had been captured. It happened all thanks to the Event Horizon Telescope, which is many radio observatories or radio telescope facilities around the world, all working together to produce a highly sensitive and high-resolution telescope. Another array of telescopes in Chile is called the Atacama Large Millimeter Submillimeter Array, ALMA. They captured high-resolution images of the 51 significant galaxies in the Virgo cluster. That's part of how we know what we know. M87 and other galaxies don't appear to be doing a lot to the naked eye. In fact, in a typical human lifetime, they barely move at all. Yet they are made up of gas, dust, and other objects that move through space at high speeds. They move when affected by the gravity of other galaxies, or dark matter, a mysterious entity that is 5 times more common than ordinary matter. Many galaxies, including our own, are believed to have a halo of dark matter surrounding them. The dark matter can pull more significantly on the smaller galaxies outside the clusters. As the galaxy gets dragged around through space, the star wrecker may come across. Giant clouds of intergalactic plasma, a form of electric gas, can behave like an atmosphere and drain the gas inside the galaxy. It sweeps out the gas inside the galaxy, stripping it of what it needs to make stars. It's hard to grasp the scale of this sort of activity, but that's what scientists now believe has been occurring to some galaxies or the nebulae without stars, as Charles Messier saw it. Now, let's park our space cruiser here and watch this thing in action. What we've been calling star wrecking is known as gas stripping. It's one of the most spectacular and violent external events in space. A scientist from the National Research Council of Canada said that galaxies are moving so fast through hot plasma in the cluster that a vast quantity of cold molecular gas is stripped from the galaxy. It's as though the gas is being swept away by a giant cosmic industrial blower. It's not the sort of clean-out we want to happen in our galaxy. You observe it in action. You're impressed, but equally respectful of its great power. The gas stripping, also known as ram pressure stripping, travels through many galaxies and removes a star-forming gas. The process is very efficient. The gas is behaving differently from the clouds in our galaxy. They aren't forming as many stars as they are in ours. A 21st century study found that the same process happens in smaller groups of only a few galaxies, with much less dark matter. The study looked at a staggering 10,567 satellite galaxies. These are galaxies that exist beyond the enormous galaxy clusters. Most galaxies in the universe exist in between 2 and 100 galaxies. They were able to study such a large number by using stacking. It makes it possible to learn about a collection of faint objects by combining all the information from the objects and making an average characteristic. They ultimately determined that gas stripping, or star wrecking, is potentially the main way that galaxies, predominantly star formation, are shut down by their surroundings. Pretty unfortunate to have such a nasty neighbor. So, now that your curiosity has been satisfied, it's best to leave this plasma cloud and get on with your journey to Outpost 52. You're going to be late now and could be in a whole lot of trouble. While the cruiser turns around, we'll head back to Earth. And back in time, back to 1744, to that night in rural France, where a teenager stood outside, marveling at the night sky and the spectacular vista of the six-tailed comet. And from that moment, was inspired to begin a lifelong quest based on a single question. Perhaps the ultimate of all. What's out there? In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome. Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It planet could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures, and pressure, and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow. Who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.